This is Colin Selleck of Binghamton University. This video lecture is the course introduction to MA 274 Dynamics, and we'll be using the book Dynamics by R.C. Hibbeler, the 13th edition. So first, let's take a look at the syllabus. The course, of course, is online, and it's 3 credit hours. I use both summer sessions, so we're going to run until about early August. There's my email address, cselleck@binghamton.edu. Of course, no official office hours, but just send email to me. And note that I only read emails 8 to 5, Monday through Friday, so plan accordingly. Since this is an online course, you're encouraged to use the discussion forum on Blackboard. Click discussion on the left side. Now, I use the terms Blackboard and my courses interchangeably. I usually use Blackboard, but the URL is mycourses.binghamton.edu. The text, it is required, Engineering Mechanics Dynamics 13th edition by R.C. Hibbeler. Online resources, you're also required to sign up at masteringengineering.com. All the homework is done online there, and you can also purchase a e-text version of the textbook there as well. Prereqs are a grade of C- or better in statics, ME 273. Homework's worth 10%. There's 2 exams during the semester, each worth 30, and the final exam worth 30%. Now, you are encouraged to work together on assignments to better understand the material, but of course, please turn in your own work. Academic dishonesty can result in course failure and dismissal from the university. And you're responsible for all the readings and homeworks listed in the lesson plan, which I'll go over shortly. This course covers fundamental issues from the field of particle and rigid body kinematics and kinetics. We use calculus, differential equation, physics, and basic engineering concepts. And we use these to investigate common problems in the dynamics of rigid body mechanics, utilizing fundamental principles involving forces and motion. Both theoretical development and applied problem solving are emphasized. Upon successful completion of this course, you will be able to explain and demonstrate the meaning of these terms: particle, rigid body, kinematics, kinetics, equilibrium, friction, and free body diagram. You will be able to describe the motion of a particle using rectangular, polar, and path coordinates. For a particle or system of particles, you will be able to compute the force-motion relationship using Newton's law, energy methods, and impulse momentum methods. You'll be able to compute the relative velocity and acceleration in rigid bodies. You'll be able to determine the plane motion and forces for a rigid body rotating about its axis of revolution. Okay, there are the ABET Outcomes. You can just read those. The Code of Ethics for Engineers, I'll just let you read that. Here are the different reading topics. Of course, we do the syllabus, the course overview, and a broad overview of basic concepts and principles. We're going to talk about motion and moving coordinate systems and different types of coordinate systems, linear and angular momentum, kinetic and potential energy, work, and also work done by non-conservative forces, linear impulse and momentum, angular impulse and momentum, planar kinematics, rigid body motion, translation, rotation about fixed axes, absolute motion, and relative motion. And in planar kinetics, we'll go over equations of motion and moment of inertia. We'll also cover work energy, kinetic energy, conservation of energy, and we'll take a look at some non-conservative forces. Course policies. Homework is to be done online at this URL. It's due by midnight on the Sunday after the module dates, and just see the lesson plan. Any work, that means the 3 exams that you're going to turn in for credit, need to be neat and professional, otherwise I won't accept it. Now, these exams are going to be administered by a proctor, which you're responsible for finding, and I'll go over that in a little bit. Do not accept late homework. Please review the Watson Academic Honesty Policy. You must submit all requests for regrading within 1 week of the return of the exam. And note that I might recheck the entire exam, and the final grade could go up, down, or remain unchanged. You'll have 2 hours for each of the 2 exams during the semester and 3 hours for the final. They're not open book, but you are allowed to bring in 1 sheet of paper with whatever the formula, notes, diagrams, etc. that you feel are needed. You may use both sides of a standard 8.5 by 11 sheet of paper. You also need to bring a calculator and writing utensils to the exams. If you require special services due to a disability, please provide a letter from the Office for Students with Disabilities. So let's go over the lesson plan. There's the text again. It is required. Again, homework is done online at masteringengineering.com. You'll need this course ID to sign up. Each module, except for the first one, has homework assignment that's due by midnight on the Sunday after the assignment week. And the first module is the week of May 28th. It's a course introduction. Please read all the course documents online and start looking for a proctor to administer the 3 exams. Module 1 is also the week of May 28th. It's on Chapter 12, Kinematics of a Particle. Here's the reading assignment, and you must also view all the video lectures. All the video lectures are online on YouTube, and if you go to Blackboard in the content section, I'll show you this in a moment, the links to all the videos are there. Module 2 will go over in the week of June 4th. That's on Chapter 13, Kinetics of a Particle, Force and Acceleration. Module 3 is the week of June 11th. It's on Chapter 14, Kinetics of a Particle, Work and Energy. And then the week of June 18th is the first exam. It covers modules 1 through 3, and you must finish it by 5 p.m. Friday, June 23rd. And then the week of June 25th is Module 4, Chapter 15, Kinetics of a Particle, Impulse and Momentum. Week of July 2nd is Chapter 16, Planar Kinematics of a Rigid Body. And Module 6, the week of July 9th, is on Chapter 17, Planar Kinetics of a Rigid Body, Force and Acceleration. And then the week of July 16th is the second exam. It covers modules 4 through 6, and it must be completed by 5 p.m. Friday, July 28th. And then we'll do Module 7 the week of July 23rd. It covers Chapter 18, Planar Kinetics of a Rigid Body, Work and Energy. And the last module is the week of July 30th. It's on Chapter 19, Planar Kinetics of a Rigid Body, Impulse and Momentum. And then the week of August 6th is the review and the final exam. Final exam is 50% on modules 7 through 8 and 50% on modules 1 through 6. And it must be completed by 5 p.m. Friday, August 11th. So let's go to My Courses or Blackboard and check out what's going on there. So the syllabus is under the syllabus section. This discussion section is the forum where you're welcome to submit questions and have your fellow students respond to them. Content is where all the meat of the course is. You can download all the PowerPoints with the text if you want to use those as a study guide. But in each module, let's go to Module 1. Each module has a reading assignment, a homework assignment, and the video links to the lectures on YouTube. And finally, let's take a look at Mastering Engineering. So if you click on the Assignments tab, here's where you'll see the assignments that you're required to do. This first one is Introduction to Mastering Engineering. It basically will teach you how to use this website and how to do the homework. Module 1 homework is here. It's on Chapter 1. Now for each of the homeworks, I do an adaptive follow-up that's due 2 days after the homework's due. And that is a specially designed module just geared towards the individual student to help reinforce areas that they may be weak on. So you can receive credit for that as well. So both of those are required, the module homework and the adaptive follow-up. All right, this completes the course introduction lecture for ME 274 Dynamics. The next video is on chapters 12.1 through 12.2. It's Introduction and Rectilinear Kinematics, Continuous Motion. See you in cyberspace.